All right, here we go. 215. Ounce of money in cents of coins carried by 10 students in a statistics class. What's the mean? The mean is another word for mean is average. So we're going to find the average. Let me get my pen going here. Sorry about that. In the average, we just add up all the data or all the numbers and divide by however many we have. So for the average, I'm going to just do 50 plus 35 plus 0 plus 97 plus 76 plus 0, plus 0 plus 87 plus 23 plus 65. And that's going to give me 433. And then I do 433 divided by 10 pieces of data is 43.3. So there's my average. 2.16 asks for the median. Now the median of the data is the middle of the data from smallest to biggest. So I have to order the data or write it down in order 0, 0, 0. Okay, so I've got those guys. 23, 35, 65, 50, 65. 50, 65, 76, 87, and then 97. So there's my 10 pieces of data. I need to find the middle, and since there's 10 pieces, I'm going to count up 5 here, and then there's 5 here, so halfway is going to be right there. So the median in this case is not part of my data set. It's going to be halfway between 35 and 50. And so how do I find halfway between two numbers? Well, I'm going to find the average of them. So I'm going to do 35 plus 50. So I add them up and divide by 2. So it'd be 85 divided by 2, which is 42.5 would be the median. So the difference is the median is the halfway point from smallest to biggest of my data. The average is the middle of the data, but it's kind of weighted. Okay, so if I have a whole bunch of zeros, my average will be smaller. If I have a whole bunch of big numbers, the average will be bigger. So it kind of depends on the value of the numbers. Okie doke. There we go. And I'm going to skip up to the next one is 217, the 5-number summary. The 5-number summary, which we will certainly be talking about in class next time, and if you've read about it, is the minimum, Q1, the median, Q3, and the maximum. And Q1 is the 25th percentile. 25% of the data is below it. The median is the 50th percentile, and Q3 is the 75th percentile. So if you think about it, of the bottom half of the data, Q1 is the midpoint, the median. Of the top half of the data, Q3 is the median. So what we're really going to be doing is finding the median 3 different times, as you'll see here. So in 215, we're going to find the 5-number summary. So I'm going to go back here, and I want to find the minimum is 0. Over here I do the maximum is 97. The median is 42.5. Now I'm going to use a different color here to illustrate this. I want to find Q1, which is the 25th percentile, or the halfway point or the median point of the bottom half of the data. So I don't include the median when we calculate this. I'm going to repeat that. Don't include the median. So what's the halfway point in this data? Well, that's right there. I've got 2 pieces below data, 2 pieces above. So the Q1 would be 0. And up here, the halfway point here would be 2 below, 2 above is 76. So Q3 would be 76. So 75% of the data is below 76, and 25% is above. 25% of the data is below 0, and 75% is above, is how that works. So the 5-number summary is this right here. Okay, so that is this right here, which should be, oh, look at that, I have to look back and see what I wrote. 0, 0, 42 and a half, 76, and 97. 0, 0, 42 and a half, 76, and 97, which would be that guy right there. Alright, so let's go back to my blue. If a distribution is skewed to the right, okay, skewed to the right means the tail goes that way. Now that is a smooth way of writing a histogram that looks like this. What we're really talking about is a histogram that looks like this, but instead of writing the histogram, sometimes we write it with a smooth curve. Now, what happens, and we're going to talk at great length in class about this, what happens to the mean and the median when we do this? Well, if the distribution is symmetric, say it goes like this, the mean and the median are the same, right there in the middle. The middle of the data and the average are right smack are the same. Now what happens if I take this piece of data right here and I cut it in half and I pull it out this way, and then I take this piece of data right here and I pull it out here and add them over here, and I get rid of, and I make it smaller? Well, this new red data set now is skewed. And I'm going to go ahead and make it right, overlay it with green. It now goes like this, tailing off here. Well, if you'll notice, I still have 50% of the data below and 50% of the data above, don't I? So the median stays the same. But what happens to the average or the mean? Well, because I have these higher values over here than what I did before when the mean and median were the same, the mean's going to be higher. And again, we're going to talk about this in class quite a bit. So back up to the original diagram, when it's skewed to the higher numbers, the median will be here, somewhere towards the bulk of the data, and then the mean will be pulled out towards the tail. Okay, so to answer this question, the mean is greater than the median. 219. What percent of observations in a distribution lie between, I gotta get rid of that, the first quartile and the third quartile? Well, up here, the first quartile and the third quartile is 50% of the data. And 220, to make a box plot of a distribution, you must know, what do I do? What is a box plot? A box plot is simply the 5-number summary. Okay, and again, we'll hit this in class if you haven't, if you're doing this before we hit in class. A box plot looks like this. It's a box where this is the minimum. This is Q1. There's a line in the middle for the median. This is Q3 and the maximum. So in order for me to do this, make this box plot, I have to know the 5-number summary. Okay, and we'll talk about why we use a box plot and so forth in class. All right, and there you go with this.